Robot Swarms and Collective Intelligence with AI. Title: Robot Swarms and Collective Intelligence with AI. Introduction. In recent years, advancements in artificial intelligence, AI, have revolutionized various aspects of technology. One fascinating area that has gained significant attention is the concept of robot swarms and their ability to exhibit collective intelligence. By leveraging AI algorithms, robot swarms can perform tasks with remarkable efficiency, adaptability, and problem-solving capabilities. This article delves into the fascinating world of robot swarms and explores how their collective intelligence, driven by AI, is reshaping the future of automation. Defining robot swarms. Robot swarms are groups of autonomous robots that work collaboratively to complete tasks. Rather than relying on a single centralized controller, these swarms leverage AI to distribute decision-making processes across the group. Each robot in the swarm operates independently, yet they communicate with each other to exchange information, coordinate actions, and achieve collective goals. Collective intelligence. At the heart of robot swarms is the concept of collective intelligence. By pooling their capabilities, robot swarms create a powerful network of interconnected agents that surpass the limitations of individual units. AI algorithms and robot swarms. The success of robot swarms heavily relies on the implementation of advanced AI algorithms. These algorithms enable robots to exhibit behaviors such as task allocation, communication, motion planning, and adaptive decision-making. Swarm-based AI algorithms often draw inspiration from collective behaviors observed in nature, such as ant colonies, bird flocks, or fish schools. By mimicking these natural systems, researchers can develop efficient swarm algorithms that optimize cooperation and enhance problem-solving capabilities. Advantages of robot swarms. 1. Enhanced efficiency. Robot swarms excel at parallelism, enabling them to divide complex tasks into smaller subtasks, executing them simultaneously. This parallel processing capability significantly speeds up task completion, making robot swarms more efficient than traditional single robot approaches. 2. Robustness and adaptability. The decentralized nature of robot swarms provides inherent robustness. If one or more robots fail, the swarm can distribute the workload among the remaining functioning units, ensuring the task is still accomplished. Moreover, swarm algorithms allow the collective to adapt to dynamic environments, making them suitable for scenarios that require flexibility. 3. Scalability. Robot swarms can easily scale up or down based on task requirements. The addition or removal of individual robots does not disrupt the overall swarm's functionality, allowing for flexible deployment and resource utilization. This scalability makes robot swarms well suited for large-scale applications, such as search and rescue missions or environmental monitoring. Applications of robot swarms. 1. Search and rescue. In disaster-stricken areas where human access is limited or dangerous, robot swarms excel in search and rescue missions. They can comb through rubble, map the environment, and communicate vital information to facilitate human decision-making, potentially saving lives. 2. Agriculture. Robot swarms equipped with AI algorithms can revolutionize the agricultural industry. They can work collaboratively to perform tasks such as planting, cultivating, and harvesting crops. By leveraging collective intelligence, robot swarms enable precise and efficient farming practices, minimizing waste and optimizing yields. 3. Construction. Robotic construction swarms can automate various tasks, such as 3D printing, bricklaying, or assembling prefabricated components. The collective intelligence of these swarms expedites construction processes, reduces costs, and improves overall quality. Challenges and future directions. While the potential of robot swarms with collective intelligence is vast, several challenges need to be addressed. Ensuring effective communication and coordination among autonomous agents, managing power consumption and resource allocation, and dealing with security concerns are among the key areas of research. Additionally, ethical considerations surrounding autonomy and decision-making in robot swarms require careful deliberation. Looking ahead, the future of robot swarms appears promising. Continued advancements in AI, coupled with breakthroughs in robotics and swarm algorithms, will unlock new possibilities in various domains. Robot swarms could revolutionize transportation, logistics, surveillance, and many other industries, redefining productivity and efficiency on a global scale. The concept of robot swarms and their collective intelligence, driven by AI, has gained significant attention in recent years. These swarms, composed of autonomous robots that work together to accomplish tasks, have the ability to exhibit remarkable efficiency, adaptability, and problem-solving capabilities. At the heart of robot swarms lies the concept of collective intelligence. This is achieved through the combination of individual robots' abilities to perceive, decide, and act independently, while relying on decentralized coordination. By pooling their capabilities, robot swarms create a powerful network of interconnected agents that surpass the limitations of individual units. The success of robot swarms heavily relies on the implementation of AI algorithms. These algorithms enable the robots to exhibit behaviors such as task allocation, communication, motion planning, and adaptive decision-making. There are several advantages to using robot swarms. Firstly, their parallel processing capability allows them to divide complex tasks into smaller subtasks, executing them simultaneously and significantly speeding up task completion. Additionally, the decentralized nature of robot swarms provides robustness and adaptability. If one or more robots fail, the workload can be distributed among the remaining functioning units, ensuring the task is still accomplished. Robot swarms can also easily scale up or down based on task requirements, allowing for flexible deployment and resource utilization. Robot swarms have numerous applications across various industries. In search and rescue missions, they can navigate disaster-stricken areas and provide essential information to facilitate human decision-making, potentially saving lives. In agriculture, robot swarms can work collaboratively to perform tasks such as planting, cultivating, and harvesting crops, enabling precise and efficient farming practices. In the construction industry, these swarms can automate tasks like 3D printing or bricklaying, expediting processes and improving overall quality. However, there are challenges that need to be addressed.